Here we have an application to higher order derivatives, position, velocity, and acceleration, and this is a type of scenario that's used across calculus, all the calculus classes, the physics. Like, this is a very known application with derivatives, position, velocity, and acceleration. So let's talk about what position, velocity, and acceleration are in terms of derivatives. So if we have the position is your S of t function. It's the original position, starting position. Then we have velocity. Velocity is the derivative of your position. So velocity equals the derivative of the position. And that's notated as v of t. Then we have acceleration. The acceleration is the derivative of the velocity, which is the second derivative of the position. So it's the second derivative of your position or the derivative of your velocity. And that's going to give you acceleration, a of t. So knowing these relationships, position, velocity, acceleration, will then allow you to answer a whole bunch of questions that can be asked in these position, velocity, and acceleration scenarios. But just understanding that position is your S of t, v of t is your velocity, which is the derivative of your position. Acceleration is a of t, which is the derivative of your velocity, which is the second derivative of your position. So just understanding those relationships will make these questions that can be asked that much easier. And not have to worry about, well, if it's asking v of t, what does that mean? What am I looking for here? Because sometimes you might even be given v of t. You might be given the velocity. So then how do you get to acceleration if you're given velocity? You just take the derivative of your velocity. If you're given position, how do I get to acceleration? Take the second derivative of position, first derivative of velocity. So let's go ahead and do these examples. So we're given this function, and this is just some generic, not anything specific. Like sometimes you'll get like a pebbles thrown off a cliff, or an object's thrown off a building, trajectory of something. Usually there's going to be some sort of application to this, but this is just generic and just understanding position, velocity, and acceleration. So the velocity is going to be the derivative of your position. So 3 times 3 is 9t squared. 3 minus 1. Plus, and this is 2t, so the derivative of 2t is going to be 2. Then our acceleration is going to be the derivative of our velocity. So let me just write that as v of t, or second derivative of position, but either way, we're taking the derivative of this function right here. So that's going to be, let me stay consistent here, so that's double prime. So that's going to be 18t. 2 is a constant, so goodbye 2. And that is our derivative of our velocity, which is our acceleration. So there it is, velocity, acceleration, position. So now the last question here is asking, find the position, velocity, and acceleration when t equals 3. Okay. So position, when t equals 3, all we're doing there is we're just plugging in 3 into our position function. So it's going to be 3 times 3 to the third. Wow, a lot of 3's going on here. 2 times 3. Just so I don't make a mental error here. 3 to the third, 27 times 3 plus 6, 87. And typically, like if we're looking at an application question, like something traveling, the position would just be in terms of like meters or feet, or I'm just going to use meters. And I know this scenario is not giving us anything, but there's a reason why I'm going to talk about this, because we want to talk about the units here. Next, let's get velocity. So for velocity, we're going to do v of 3. So our velocity function was 9 and then plug in 3 for t. So that's after 3 seconds is, or 3. It's not giving us any scenario, so let's just call it seconds. So t is equal to 3 seconds, so 9, 3 to the second plus 2. Three to the second is 9. 9 times 9 is 81. 81 plus 2 is 83. So the units on velocity is going to be meters per second. Meters per second is the velocity. And if this was like feet or something, or minutes or hours or something, it would be feet per second, or just feet for the position. But acceleration, it's going to be the derivative. Sorry, we already got the acceleration. We're plugging in 3 into the acceleration function. So our acceleration is 18 times 3. So 18 times 3, just double check my mental math there. Yeah, 54. So 54, and then the units on acceleration is meters per second squared. Meters per second squared for acceleration. So understanding the fundamentals and the basics of your position, velocity, and acceleration will then allow you to answer pretty much any question from here, because from this point on, like, this is just the foundation of position, velocity, and acceleration, but then there's a lot of different types of questions that can be asked from just this scenario here. So it's understanding position, velocity, acceleration, derivative, second derivative, and you're good.